Continuing with our 2.7 discussion on sets and set notation, since the set of real numbers is non-countable, we have to use set builder notation to indicate what we have in our sets. So to define the elements of subsets in real numbers, it's sometimes necessary to use inequalities. And when this is the case, we can employ a real number to graphically represent a set. We can call this set interval notation when we see it on the number line, but we're indicating an interval of numbers that includes a set of values, not just individual one-by-one numbers. So, for example, if I said a subset of the set of real numbers is given by the set of all x, such that x is greater than or equal to 0, but less than or equal to 7. Right? We are finding the set of all real numbers between 0 and 7 and including 0 and 7. So on a number line, we would show this by indicating two square brackets at the ends of our set, a square bracket at 0, a square bracket at 7 to indicate that we are including our two values, 0 and 7, and darkening in the number line to indicate that we're including every number along that interval. It's a continuous set of values along that interval, not just the fixed values 1, 2, 3, 4, 5, and 6. If we're graphing sets on the number line, sets that are countable could be indicated on the number line by just using points, right? But sets that are not countable can be indicated by using a solid line. We call these sets continuous. We always say that the set of all real numbers is continuous. Right? So the set of real numbers is continuous. And in algebra, the solution of inequalities are always continuous sets, as we'll see later. So if we have a continuous set of real numbers, such as an inequality, we're going to use interval notation. So let's indicate what our notation will be. We're going to use the round bracket for greater than, round bracket facing to the right. We're going to have a round bracket facing to the left to indicate less than. We're going to have a square bracket. Sometimes an old professor called it hard bracket, used for greater than or equal to. And a square bracket facing to the left for indicating less than or equal to. And these will be our correspondences whenever we write our sets on the number line. So let's write in interval notation on the number line. An open interval is when we use round brackets at both ends. So for example, the set of all x in the set of real numbers, such that x is between 1 and 8, not including the endpoints, would be indicated on the number line this way. Now, if we had a closed interval in which the endpoints 1 and 8 were included on this continuous set, our set would look similar, except we would be using square brackets at those endpoints instead. We can have a half-open interval in which one side includes a hard bracket and the other side includes the rounded bracket. So for example, the set that includes 1 but not 8 at the end point for all x in between would be indicated this way. Intervals can also be infinite. When we write x is greater than 5, we only need to indicate one endpoint on the number line and indicate all the other end of the interval continues on infinitely. Thus, our set of all real numbers of x such that x is greater than 5 would be graphed as a round bracket at 5 facing to the right and an arrow, solid line darkened in, and an arrow pointing off to the right along our number line. We do not need to indicate the other end line because it goes on to the end infinity. Okay. Here's some other examples. Let's use the number line to graph the set of all real numbers x such that x is between -3 and +3, including the endpoints. I'll give you a minute to do that. Okay, our set would look like this. If you graph this on your number line, you did well. That's exactly right. We include the hard brackets at -3 and +3 and darken in all the numbers in between. Let's try it the other way around. What if we're given the set on the number line like this one? take a moment and write out your set builder notation for this one. Okay, did you get x such that x is greater than or equal to 4? Perfect. That's exactly what you should be getting right there. Now, algebra relies almost completely on the set of all real numbers, and so for convenience, we're going to use an interval notation that reflects our thinking on the real number line. So specifically, instead of writing as we do in set builder notation, let's say the set of all x such that x is between negative 15 and 20, not including the endpoints, we can instead use the notation with an open bracket, negative 15 at one endpoint, comma, 20 at the other endpoint. And look how this almost exactly mimics what we would see on the number line. On the number line, we would be putting round bracket at negative 15 facing to the right and a round bracket facing to the left at 20. Negative 15 is one endpoint, 20 is the other endpoint. And since we're filling in all real numbers in between, we're going to assume that when we see this notation, that's exactly what we mean, the set of all real numbers on the continuous line from negative 15 to 20. So in general, when writing sets of numbers using interval notation, here's our rules. If we say the set of all x such that x is between two fixed endpoints a and b, including the endpoints, we're going to write two open brackets where a and b are inside of those brackets separated by a comma. For a half open set, we can write it one of two ways depending on which way the greater than or equal to symbol is or less than or equal to symbol is. And for an open set, we're going to say the set of all x between a and b such that the sets a and b are enclosed within those two rounded brackets instead. So this is going to be a shorthand notation instead of having to write it on the number line each time. So there are some further rules. We can say if we don't have a fixed endpoint or a closed set, we're going to include negative infinity as one of the endpoints. So the set of all x less than or equal to b would be an open bracket around the symbol for negative infinity. That symbol looks like an 8 lying on its side is infinity. It means it continues on without bound to the left, up to and including b. The set of all real numbers greater than or equal to a would be indicated by a square bracket facing to the right around a, comma, the symbol for positive infinity, which is just the symbol for infinity without the negative sign, and a round bracket around infinity. For the open set of all real numbers less than b, we're going to put a rounded bracket instead of a hard bracket around b, but otherwise it is the same as our first set. And likewise, for the set of all x greater than a, but not including the endpoint, we're going to include a round bracket around the endpoint a. Note that for each of the endpoints right here, whenever we have infinity as the endpoint, we put a rounded bracket around that symbol. That's to indicate that the set is not bounded by an endpoint. There is no way to reach infinity. In fact, infinity itself is not a number. It's the concept, the set of all numbers that increase or decrease without bound on the number line. So let's try it out. Let's say we want to write the interval from negative infinity to 5 in set builder notation on graph it on the number line. Well, let's see how this would look. Since our interval notation mimics exactly what we would see on the number line, what we would have to do is we would indicate that we're going to include positive 5 facing off to the left in our set. So we're going to put a hard bracket around 5. And we want all real numbers to the left of negative 5, so we're going to shade in our number line everywhere to the left of positive 5 to indicate that we're including all of those real numbers. And we put a real arrow at the end of that to represent that particular idea. Okay, so this is our set from negative infinity to 5. In interval notation, by the way, we should be able to rewrite this, and we would write it this way: the set of all x such that x is less than or equal to 5. And that looks sort of like a familiar thing that we've seen before. In fact, it is. Well, let's try it the other way around. What if we're told we want to write the set of all x such that x is between -3 and +9, including the endpoints, in interval notation and graph it on the number line? Well, we could graph it on the number line very, very easily. We know that we're going to put a hard bracket facing to the right around -3 and a hard bracket on +9 facing off to the left, and shade in all those elements in between these two numbers on our number line. So when we write these values right here, I'm just kind of doubling up on my line right here, that's what it looks like on the number line. And our interval notation mimics that. We would write in interval notation a square bracket including -3, comma, and a square bracket around 9. Come on now, square bracket around 9. My pen does not like me when I do that. 9. And there we go. That's our interval notation. Have a great time with your homework, and good luck.